therapy, model system, cancer research, and toxicity testing, and virology and genetic engineering. So after seeding of the cells, seeding of the 96 well plate, we can identify the sudden concentration, IC25 or IC50 or IC75, and then later we can go for. We can measure the therapy, model system, cancer research, and toxicity testing, and virology and genetic engineering. Concentration to treat the cells and the cells. Seeding of the 96 well plate, we can identify the sudden concentration, IC25 or IC50 or IC75, and then later we can go for changes of the cells. We can measure the therapy, model system, cancer research, and toxicity testing, and virology and genetic engineering. Concentration to treat the cells and the cells. Seeding of the 96 well plate, we can identify the sudden concentration, IC25 or IC50 or IC75, and then later we can go for changes of the cells. We can measure the therapy, model system, cancer research, and toxicity testing, and virology and genetic engineering. Concentration to treat the cells and the cells. Seeding of the 96 well plate, we can identify the sudden concentration, IC25 or IC. Apoptosis is the programmed cell death, and then necrosis is the unprogrammed cell death. It will happen on the cell systems. These are the morphological of apoptosis. It will be shown the membrane bleeping changes. It will be happen in the membrane. The mitochondrial changes, it will be happen in mitochondria, and then nuclear fragmentation, it will be happen in nucleus, and organelle reduction, it will be formed into organelle. Chromatin condensation, it will happen in the surface of the mitochondria. So these are the morphological changes events, and bleeping of the cells, it will happen like this. The cells will be damaged in the intramedullary wall. It will be produced in the apoptotic body. The apoptotic body develop into the different way of pathway, and then especially in mitochondria. So this is one of the criteria. The cells will be mainly due to the form in the cell death due to form in only the apoptotic pathway, or several pathways are there. Mainly the cell death pathway will be mitochondria. So these are the pathways of DNA damage. P53 bags are these are the proteins available in the biome to verify the conformation of mitochondrial pathway or OS pathway. So the flow cytometer analysis is a very crucial part in the cell death to detect the flow cytometer. The flow cytometer, the flow of laser, we can identify the cyto. The cyto means cell, metry means flow cytometer. We can easily identify the flow cytometer. The principle of a flow cytometer is defined flow system, fluids, and optical system, light sensing, and the electronic system, signal processing. You can see this, the laser will be produced, the cell will be flowing down, it will be emitted into there are different way of laser. It will be absorbed, certain particular laser. So there are many states are there in cell. In cell state, we can find the immunophenotyping, cell cycle, apoptosis, and cell proliferation, cell function, cell activation, calcium flux. There are so many types of cells there. We can confirm that these are the states we can confirm by the flow cytometer, which has been used with the potential application. The flow cytometer mainly works on hydrodynamic focusing. The hydrodynamic focusing is nothing but the particle pass through the cell beam. It will be formed in the movement. And then we can prepare the high flow rate or low flow rate. It will be high flow rate, it will be phenotyping cell analysis, and low flow rate, it is DNA analysis. So there are two scatters are mainly used in the optics. One is forward scatter and the side scatter. The forward scatter is refractive index, and it will be calculate refractive index and cell size permeability, and side scatter will be confirm the granulars and cell involution. So the formation of FSC and SSC do allow the differentiation of different types of the cells, the like granulocytes, monocytes, lymphocytes, and debris also. Finally, it will be calculated into the dead cell. These are the granulocytes, these are the monocytes, these are the lymphocytes, these are the debris. So there are several fluorochromes are available. We can use, there are these kind of stainings in flow cytometer. You can, mainly we are using FITC and PE or PA. So finally we are using annexin 5 FITC. The annexin, it will be on the healthy cell, it will be shows the green cell population. After that, early apoptotic cells will be shown in red color, and the nuclear damages, and the finally nucleus. It will be emitted in the, there are 4 quadrants we can find. One is viable, this one, Q1, and early apoptotic is Q2. This one is Q3, necrotic or late population. This one is purely necrotic. So this is our lab, obtained the untreated cell and treated cell. We can obtain like this image in our biomi. So not only we can find the apoptosis, we can find the cytokinin with a specific antibody with the using of fixed and permeable. We can analyze the different cell inhibitors like a T cell or B cell. So then move on to cell cycle analysis also we can perform. The cell analysis is a different pathway. G0 increase, G1 is increasing size, S phase is the DNA synthesis, G2 is growth population. Final stage we can obtain, sorry, this one is image is not properly, it's coming. So we can find the population in the G01 and the S phase arrest and G2M. So we can find these are the debris, and you can find the G1 peak, and this one is S phase and G21. G1 is apoptotic cell, and G1 peak is non-apoptotic cells. So these are the mechanism. We can find the how it will be performing on after flow cytometer. The fluorochrome is emitted into the cell membrane. It will be formed into the cycle. It will be damaged on the cell cycle. So the final result of cell cycle, it will be like that. The cell S phase arrest, it will be happen in IC50. G2M bar, this one also will be occur after IC treatment with IC25 and IC50. So the PCR analysis, we are performing with QIAGEN software with the 5-plex model of RT-PCR we are using in our lab. So it will be confirmed to the 5 to 3' primer. So PCR is nothing but the real time on the progressive of specialized technique to identify the DNA sample out to the state the reaction. We are mainly using the cyber green groups with different concentration and with different temperatures. So the RT-PCR is mainly used on the medical research and drug research. Not only the medical gene expression analysis, the gene expression analysis is the diagnosis process. It will be used on the viral quantification, food testing, and transgenic research. The transgenic research is the recently developing and progressive model of the mainly used on the RT-PCR. So there are 3 steps are mainly in PCR products: denaturation, annealing, elongation. The denaturation is 95-degree fixed temperature, and then annealing is formed into the absorbing the fluorochrome into the cells. After that, finally we can choose the extension in our own model. So the PCR application is second generation application, 3 to 5. We can develop into the different model of the applications. So we can confirm the PCR application. Analysis of the PCR products is mainly gel electrophoresis, southern hybridization, restriction digestion, and a direct model of 95% mutation. The fluorescent PCR, we are using the fluorescent PCR with the using of cyber cream, not only cyber cream, as per their requirements, we can change the different kinds of the lasers. So the advantages of PCR and RT-PCR, the PCR is only the, it will be stained into this, stained into the treated cells, strain A, strain B, strain C, strain D. We can find the 4 primers in the single tube. But in RT-PCR, we can quantify as well as genotyping, mutation detection and gene expression also we can perform in the RT-PCR model. It will be less expensive, detect point mutation and the exact quantification of the cell death or gene expression levels. We have discussed, we have using a Quiagen 5 cell cycler. We can use at same time, we can use the 5 different type of cycler. If we want, we can elongate or we can use or we can develop further model. When performing the cycle, the result is are okay, we can add into the different level of cycles on the while performing the instrument. That is main point. When performing the experiment, we are getting a positive results. So we can add the cycles. Whatever we want, we can add the cycles. That is the main advantage of Quiagen 5 flex cycler. So that's why we are using. So now at present we are available in different kind of genes. Only we are not only these genes are we are using, but we are using all kind of genes. But these genes are very readily available. If anyone want, you can use it. So yeah. So this is the flow cytometer and RT-PCR of in our laboratory, mainly using these kind of experiments in our lab.
Okay, thank you. It's an open bar discussion. If you have any doubt, you can ask me about our presentations. And if you need any this kind of service, maybe you can ask us. We have already provided our pamphlet with your back, right? So maybe you can go through it. Maybe if you need price details, maybe you can send us a message through WhatsApp or mail. We will send to the price list. Okay. Any questions? No? No questions? Yes, ma'am. We are doing bioimaging studies using fluorescence microscope. You mean you have fluorescent compound, right? You wanted to treat with some cells and you wanted to visualize that. Yeah, we are doing. We already did lot of studies related to that. Okay. We have different filters. We have different filters. Based on your UV excitation, we can do that studies. Yes, ma'am. Please.
So we are synthesized many organic compounds are very more millions of compounds. And what we want to move, what we want to know to how move to the drugs. What we want to study for the drugs.
Actually, first you can see, first you can check the MTT or cell viability assays using different cancer cells. We have maintaining the 8 to 10 cancer cell lines and 4 kind of non-cancer cell lines. First you have to check, and then the dose response of the concentration level of your compound is good, you can choose further studies. Okay. Yeah, first you should have to check the MTT or CCK8.
What are the nature to need the compounds, sir? What are the nature? Very solid, important nature.
Solid or liquid, it may be whatever it is.
Okay, sir.
It's no problem.
Thank you, sir.
Thank you.
Hello, sir. First of all, thank you for your presentation. So I have one doubt regarding the IC50 value determination and IC25 value determination. So you have mentioned the value or the figure in a slide. So IC50 value means in which concentration the cell comes down, like 50% of cells are alive and 50 is dead. So determining IC25 value is important, sir, or is this approved by FDA?
Yeah, while I am doing PhD, the reviewer raised the question why you are using IC25 instead of IC50.
Sorry, sir, I couldn't catch your point.
While I did my PhD, the reviewer raised the question why you are using IC25 instead of IC50. So the same question you are asking. Okay, first initially low concentration you should have to take without affecting the non-cancer cell line is a very important tool, first thing. And second thing is with your low concentration, how much of the cell death population was occur in the particular system. You should have to measure that. So that finally, now people are going IC50 or IC75 also. So finally, if you are using IC100, all the cells will be died. So reverse, you can use IC25. You can find the solution. You can also obtain the final results, which mean IC25 is a low concentration. It will be induce your compound. It will be means your compound induce minimal concentration, this much of percentage of the apoptotic cells in the whole system. So if you are go to IC50 also, no problem. IC25 you can find the minimal concentration, how much amount of the cell death induced. So you can find that. So that's why people are using IC25, IC50 or IC75. Yes. Thank you. Thank you. Anybody questions from flow or RT-PCR or something else? Okay, thank you.
Any other questions? Okay, thank you, sir. Thank you for your nice presentation. Thank you so much, sir.
So next. Next, it's my pleasure to invite the introducer, Professor Dr. Kalia Swarnalatha, ma'am, for the session. She has done her UG degree in Sri Meenakshi Government College, Madurai, and PG in American College, and PhD from Madurai Kamaraj University. So, she has also undergone a summer research fellowship in IIT Madras and also a postdoctoral fellow. She is currently leading the Department of Chemistry in Manoanmaniyam University, Tirunelveli. She is a physical chemistry professor. She has guided many PhD students, MPhil, MSc, and under his guidance. She is also served as a reviewer for a journal of environmental biology and Board of Studies member in MS University, and also a member of World Academy of Science, Engineering and Technology, and a member of ISRAPS BARC Mumbai, a member of European Photochemistry Association. She has completed many projects under the different funding agencies like DHT SERP and projects based on the ruthenium complexes for light harvesting system. So ma'am has established many journal articles, review articles, and published 3 book chapters. With these few words, I now invite Dr. K. Swarnalatha ma'am to deliver the speech on topic light harvesting devices and material. Welcome you ma'am, the session is for you.
Good afternoon to all. Thank you, sir. Thank you for your kind words. At the outset, first, let me thank the College Department of Chemistry for organizing such a wonderful event, Expanding Frontiers in Chemistry. So I especially thank the head of the department for inviting me to deliver the lecture on the topic Light Harvesting Devices and Materials, Recent Trends and Application. I know how hectic it is to listen a lecture after a lunch, and also for the past 2 days you have been dumped with so many informations. So I will try to give the glimpses of light harvesting devices and systems and why there is a need for this alternative energy. And then those who are really interested, I will go depth into the research. Then I'll try to complete in time. Okay, so I have outlined my talk on energy challenge, clean energy alternatives and a lesson from nature, solar energy conversion and its storage, light harvesting materials, solar light driven devices, and what are the challenges and opportunities available in this energy scenario. And finally, I'll end up with the emerging technologies and the new directions in this area. So before starting, why there is a need for this energy, and whenever we are talking about this energy crisis or energy scenario, so suddenly they will give the topic as oil crisis and what is the price hike about your petrol, diesel, and why there is a need for this energy, alternate things and solar photovoltaics everywhere, and almost we all have been exhausted on debating about these topics. Yet, so we know that energy from the textbook level, so is the ability to do work, and then various types of energies are available, and among these energies, and among the various energies available, today we are going to concentrate only on that luminous energy, that is our solar energy. And we know that renewable and non-renewable energy systems, the two biggest challenges in front of mankind today we are facing in the modern era are the rapid depletion of fossil fuels and the control of carbon dioxide emission. Even our government has insisted by 2040, our vision is net zero emission. So we all are working towards it, and there arises this energy and other things. So two types of energies. One is your renewable energy and other one is non-renewable energy. And among that, renewable energy, so you might have studied from school days itself, I will not go deep into that. So the thing is, we are abundant with these renewable energy sources. So realizing the importance of these things, our government has allotted and funded to implement renewable energy sciences department in almost all the institutes and central universities. Even in our department, in our university also, we are having separate renewable energy department, renewable energy science. Okay. So here, sunlight, wind, rain, tides and waves, and from geothermal heat. And non-renewable energy sources which cannot be reproduced or generated or used on a scale which can sustain its consumption rate. So why not coal? So majority, almost 50% of our energy need is from coal only. But the thing is, as a chemistry point of view, because of this air pollution, we have to look for clean coal technology. And the other one is nuclear energy. So from nuclear power plants also we can generate enormous amount of energy. But the thing is, we need that source. It is very, very expensive, and also still, though we have educated, still we are having the threat about the radiation leakage. So about your diesel and other things, so everywhere oil crisis. So during at night time all of a sudden they will increase the price of petrol and diesel, and we have suffered a lot using this one. So there is a oil crisis, in turn energy shortage. So apart from these things, about your global warming, pollution problem, and rising ocean, and another topic is your climate change. It is related to your rising ocean. Okay. So above all, and we know how this COVID-19 pandemic, how the scenario has totally changed, and post COVID-19 pandemic period, how we have suffered, and almost our economy has been down, and slowly we are recovering, and based on that thing, all our business and everything, it has been come into picture. So these things happen because of urbanization, industrialization, and above all this human population. So the thing is, though industrialization or our human population come into picture, we as a chemistry people or our chemistry community, we are looking into the efficient catalysts which are necessary for realizing the chemical energy storage as a solution. So just I am giving a statistics to highlight why there is a need for alternate energy source. So during 2018, see from oil, coal and natural gas and the other renewables which includes wind and solar, they are comes around 1.7%. By 2020, it has been slowly increased from 1.7 to 5.7%. So another statistics to highlight the emergence of solar photovoltaics. So by 2010, it is only 0.06%, and slowly it increases. And by 2017, it is 0.7%. The world energy outlook, this data, it has arrived during 2019, and it is released by the World Energy Outlook. And see, as government insisted, by 2040, so here I have given the coal, natural gas, oil, and another important thing is CCUS, that is carbon capture and utilization, sequestration. Okay, so that zero carbon emission is our next vision. By 2040, we have to acquire this one. So what is this CCUS? Another technology to achieve net zero emission. And the people who are working under this energy criteria, they have that focus towards net zero emission. So what it is I have given. So the possible options to meet the energy challenge by 2050, it is going to be mainly by carbon neutral energy, nuclear power, and then renewable energy sources. So under these renewable energy sources, particularly solar energy, which is striking the earth by this gigawatts. Okay. Alternative fuels, it may be made out from biodiesel and ethanol. So, and we people, I am from Tirunelveli, though I am in the soil only I came, but now I am in Tirunelveli, and those Tirunelveli people, they are very fortunate because they are enriched with almost solar energy sources, and nearby they are having Kudangulam, so nuclear power sources, and hydropower, Agastya Falls is there. And apart from this, solar energy is also available. And one more thing, I'll come little later about your Kamuti solar power project. Okay. So today's talk is about this solar energy and how we are going to store this. Okay, so how we are first going to convert the solar energy into useful energies, and then how we are storing it. So I'll not go deep into that. The solar energy absorption, since most of you are postgraduate students, I have brought this one. Yet by photosynthesis, we can capture approximately 3000 exajoules per year, 10 power 18. You imagine how much of energy can be derived. Here I have given. So the total solar energy absorbed by Earth's atmosphere, oceans and masses, it is approximately I have given. So based on this, the solar energy distribution, it is almost in your ultraviolet region, visible region and near infrared. So whole of your visible region comes under from 350 to 750. So based on this thing, the researchers or scientists, they have designed and tuned the photosensitizers to capture it. So what is the lesson we actually learn from nature? So this is the base, or we copy the principle behind this photosynthesis, and then based on that we have developed light harvesting devices and systems. So from the textbook level, we know that photosynthesis, the green plants prepare their own food with the help of 4 ingredients, the very same story only, but in a different angle. That is 2 steps taking place. One is splitting of water molecules. During the splitting, enormous amount of energy and electrons are released, and those things are utilized for the reduction of carbon dioxide. So usually in the 2 different reactions, they will do it in a separate way, light reactions and dark reactions. So this energy conversion and its storage, here I have classified into 2. One is based on artificial photosynthesis, and the other one by means of solar cells. So photosystem 1 and 2, and how your light energy, it is absorbed and it has to pass the electron cascade, and then finally it forms the energy. So the light energy, they are stored in the bonds of sugars. So based on that thing, so you recall the structure of chlorophyll pigment, porphyrin system, alkyl chain tail. Okay. So based on that thing and the principle, so they have exactly mimicked the natural photosynthesis. So here you are having the photosensitizer, and another one acceptor unit, and another one is your donor unit. So where your oxygen evolving complex, and another one is your splitting of water molecules. So it is a simple schematic sketch highlighting how or an artificial device or system can be developed. So water splitting reaction, another example and the famous one is, so without this Honda cell, we can't talk about this water splitting reactions, or in turn your carbon dioxide reduction. So light reaction, dark reaction. So the exact thing happened in your natural photosynthesis can be mimicked in the laboratory. So the photosensitizer, the chlorophyll pigments, here the ruthenium complexes, they can serve as the photosensitizers. So another example highlighting your reduction of your carbon dioxide. So second category, that is your solar cells. So based on that energy absorbed by the earth from sun, so they have calculated the efficiency, and then in turn your solar cells. So there are 3 generations of solar cell: first generation, second generation and third generation. And this third generation is your nanocrystalline cells and dye-sensitized to solar cells. And any dye-sensitized solar cell will be like this one. So the sensitizer plays a major role, and it is going to decide the efficiency of any cell. And he is the pioneer in solar cell, dye-sensitized solar cell, Professor Michael Greatcell, and he has won the Millennium Technology Prize during 2010 for fabricating this cell, and he has achieved nearly 11%, and now they have varied the photosensitizers, and even they have approached 28% of efficiency. So hydrogen fuel. So some 10 years back, we have much worried, and also we have scared about using the gas fuel. But nowadays, everywhere in almost all the bulk petroleums, they are having this hydrogen fuel, and we even the auto rickshaws and motorcycles and even your cars, they are powered with hydrogen. Okay, a simple mechanism highlighting how this hydrogen is expelled. And then solar light driven devices, almost this solar panels, it has been entered into all sectors, starting from home. Okay, so even see in satellite wings also we are having this solar panels. So since solar energy is very, very abundant, they have developed systems to trap that energy and then they will utilize at the time of consumption. So I have to highlight the recent trends in light harvesting systems and devices. Here I have highlighted solar photovoltaic technology, passive solar technologies, solar water heating, solar process heat, and concentrating solar power. This solar panels, they are, I won't say it is outdated. This concentrating solar power, it has come into picture. So it is the first hydrogen-powered train. It was introduced by Alstom's Skardia Island in Germany, and it is fully powered with hydrogen fuel only. During 2018, it has been launched, and even they have traveled up to 140 kilometers per hour. And the beauty of this hydrogen-powered train, it lies in the clean energy storage technology, that is low noise and zero emission. So since the expelling thing is your water and water vapor, so it won't create any hazardous to environment. So almost all have moved toward this one. And even in India, they have introduced and then they have manufactured it in Haryana. And by December 2023, almost it will come into picture. So our India, our country is also going to equipped with a hydrogen power train. And solar panels at home, so everyone knows the history, and even our government has given subsidy about 30% for the installation of solar power panels in our home itself. So I have given the advantages. So environment friendly, low to no energy bills, no electricity lost in transmission, and improved grid security, high electricity generation during peak hours. And solar farming, some 5 to 6 years back, so everyone, they have started investing on this solar farming. The very same solar photovoltaic technology is behind that one. So it is your photons converting into electrons. Okay. And this is the thing I have given, concentrated solar power. Instead of flat solar panels, in order to increase the efficiency of the cell, they have given the lens in an inclined position. So that we can concentrate a larger area of sunlight onto a receiver. So this thing is already in almost all European countries, they are having this concentrated solar powers. So in a little bit increase in efficiency, see, they have towers like this. Okay. So this one was first installed or accounted in Spain, and later on China overcome those things. So concentrated solar power panels. The only disadvantages, due to the high intensity, the birds are attracted towards it and they have lost their lives. So for this thing only they have, they are looking for the remedy for it. So the next one is, if we are not having any bare lands, in such cases, how to work out these solar panels in the water bodies. So for this thing also, we are having photovoltaics, that is floating photovoltaic panels. Okay, so the thing is we have to look for buoyant material, and that material, it should not be easily corroded. So all the limitations or the disadvantages or drawbacks or the problems in front of us, and we can work towards it. So that's the thing I want to stress here. Next. See, in India, in Andhra Pradesh, we are having this photovoltaics. So what are the advantages and disadvantages? Mainly based on the efficiency, and we always look for the cost effectiveness. So based on that, I have given the advantages and disadvantages of solar power panels. And within some 3 or 4 years, I am damn sure that almost all our homes will be equipped with solar panels only. Government will insist, and after 4 years, definitely you will remember me. And just I'll highlight 1 or 2 examples actually from our laboratory, and mainly based on the light harvesting complexes and the redox catalysts. We concentrate only on the photosensitizers and not on the electrode or electrolyte parts, only sensitizers. So the judicious choice of the sensitizers will enhance it will increase the efficiency of the cell. So based on that thing, we have developed. Before that, we know that ruthenium polypeptide complexes, they are toxic, and then why you always go for these toxic substances? The beauty or advantage of using ruthenium polypeptide complexes is based on the excited state lifetime. See, we can also make use of organic dyes, but yet the lifetime differs. So this organic dyes, it also having excellent stability, donating ability, aggregation resistance, extended pi conjugation, and above all this homolumi energy gaps, everything. Yet some organic dyes, I'll skip, coumarin based sensitizers, porphyrin, which will exactly mimic the chlorophyll pigment of our leaf, and phthalocyanine based sensitizers. So I have given the efficiency of the cells which are made use of this dyes. Coral based sensitizers. So exactly the sensitizer, don't apart, accept apart. Metal complexes. The efficiency, please look into the efficiency. Okay, so the main advantage of using metal complexes over metal-free complexes lies in the improved photovoltaic performance. So the 3 things are responsible for this photovoltaic performance. Among the 3, that excited state lifetime plays a major role. So they often go for ruthenium polypeptide complexes. So because of that luminescence nature and broad absorption, so our aim or focus lies in the swipe of entire solar energy spectrum from 350 to 750. So this ruthenium polypeptide, it has a broad absorption spectrum and suitable excited and ground state energy levels. Above all, this long excited state lifetime attracted almost all the researchers to work towards this one. And above all, good photo and electrochemical stability. Our compound, it should not get charged on long exposure to solar radiation. So that is also very, very important. So these are the things we have synthesized in our laboratory. So instead of bipyridine, we have also synthesized terpyridine. So instead of NN, we have also concentrated on NOOO and then NN. So with all these, nearly we have synthesized 33 new type of ligands, and among the 33, nearly 7 molecules we have got single crystal also. And apart from this, bimetallic sensitizer also, which exactly mimics the Z scheme photocatalyst for water splitting. Okay, so bimetallic ruthenium. So you might have heard about bidentate, tridentate, and tetradentate. Also, we have synthesized. See, panchromatic sensitizer. So one example where we have synthesized amine functionalized ruthenium 2. So INH2, usually they will go for acid substituted ruthenium polypyridine sensitizers. We have tried with amine functionalized ruthenium sensitizer. So along with that sensitizers, we have added these two co-sensitizers to enhance the efficiency. So I'll not go deep into the characterization. Co-sensitizers. So this co-sensitizers strategy will helpful in calculating, or it will control the reorientation of our dyes on the TiO2 plate. See the efficiency. So for sensitizer alone, it is 5.44. When it is co-sensitized with indole and that thiophene moiety, it slowly increases. So by the judicious choice of the sensitizers and the substitutions over that sensitizer, we can tune the efficiency of the cell. Similarly, instead of NH2 groups on one of the pyridyl rings, we have substituted in almost all the rings, and the efficiency is not that much because in the previous case it comes around 7 and here it is 5.14. So the combined effect of amine group as an anchor and as well as the co-sensitization strategy, it increases the efficiency of the cell. And another example, a biomimetic model for artificial light harvesting antenna system. So in the previous lecture, you might have heard about that fluorescent dyes and then about your various cell assays and activities. So here also we are having that BSA protein. Okay, so just to highlight the antenna system. Okay, so how it works out. So I'll go directly to the results. And those who are really interested, and let me know, I will give, or you can refer our journals. So with the help of synchronous fluorescence spectra and conformational investigation with the help of FTIR and by circular dichroism, we have concluded how this coumarin dye, it has been encapsulated in the BSA protein and how it is acting as the antenna system. One simple calculation is there to calculate it. So with this, the energy efficiency, it is highlighted. So the very same thiophene and then indole coumarin based dyes has been encapsulated in BSA. So it exactly mimics the light harvesting system using functional ruthenium 2 sensitizer with BSA. So almost all the, see the energy transfer efficiency, everything we have calculated, and it is a simple system for highlighting the artificial light harvesting antenna system. So another one is water splitting reaction in artificial photosynthesis. It is quinoline based ruthenium 2. In the previous example, almost all are coordinated through N. Now we have changed this. So in the previous example, the coumarins, they are added as co-sensitizers. Here we have tried and then coupled this coumarin here. So water splitting reaction, the very same thing we have mimicked as happened in our natural photosynthesis. So it highlights about the synthesis. I'll go to the see, with the help of this expression, the efficiency of photoelectrochemical cell water splitting efficiency. We can calculate it from this graph. We have to take the values and then the efficiency of this cell, it can be calculated. So these are blank experiments to conclude the optimum conditions. And then photo-induced electron transfer reaction by this quinoline-based ruthenium moiety with TiO2 nanoparticles to highlight, and the dye-sensitized PECS with a maximum photocurrent density of 11.07 was found under illumination. These are the optimum conditions. So maximum water splitting efficiency is found to be 4.98%. So even with 1.1 also has been reported, but our idea is to highlight the role of sensitizer. And final example, functional mimic of photosystem 2. So here, the very same quinoline-based ruthenium complex reaction with benzoquinone we have carried out, and it exactly mimics the photosystem 2, how the electron relay it is going on. Artificial photosynthesis, so exactly mimicking one of the harvesting units. Okay, so the very same thing, synthesis, and then excited state, intramolecular proton transfer, and some PCET, that is proton coupled. These are the kinetics we have followed. And see, the first one at pH, how the protonation, deprotonation process takes place, and on excitation, what will happen to our sensitizer, and excited state intramolecular proton transfer has been taken place, and the introduction of quinone leads to the formation of this encounter complex with the generation of your benzoquinone radical with regeneration of the very same photosensitizer. The cycle, it goes on. Likewise, the simultaneous ESIPT and PCET reactions, they are explained here, and it is a best example for mimicking photosystem 2. So I have given 4 examples. I have limited it due to the sort of time. So the only thing I want to highlight here is, so many opportunities are available in this solar energy topic or title. So design of photocatalysts. We can synthesize as many photocatalysts to improve that energy, and it is, don't think that all the solar panels can do the very same thing, and what is unique in your work. So we chemistry people actually look into the exact kinetics, and how we can improve that is our idea. And cost effective. So we have to look for low cost material which can meet out the things. So think for smart materials and smart devices, and ultimate aim is we should increase the efficiency of it. So let me summarize. So that solar energy, light energy, it is not only any energy, but it is also a stimulant and a probe. Not only a messenger, it is a trigger and a tool. So no light, no life. It finds its applications in various fields. Here I have highlighted only the electricity current generation. So we have to look, harvesting light and storage of it is the need of the hour. So by 2030, almost everyone will talk about this one. So from the fundamentals, that is from the lesson from natural photosynthesis, we have to move to the technological design. So these are the facilities available in our laboratory. Apart from that, we are having central instrumentation facility in our university. So finally, I thank my research supervisors and the funding agency for doing all this work from DST and CSAR, and our university has also supported at the early stage. And above all, I thank my research scholars because without their help, I can't stand here. So I really thank all my scholars, and this is my department and this is our university. So, and I finally thank all of you for your patience listening. And if you have any queries, and particularly the scholars and students, don't take everything playfully because your faculty members, they are arranging such wonderful event, and here is the platform where all the young researchers can unite and then they will do. So definitely, I don't know whether you can understand deeply or anything, but definitely it will be an exposure for the young minds. And once again, I thank all the faculty members of Department of Chemistry for this opportunity. Thank you.
Any question from audience side?
One of the instrument you have in your lab.
Solar simulator, it is actually in our laboratory we are having the solar simulator device. So the exact solar radiation, it can be generated from this device. So they have given simulator. So it is very, very powerful and highly intense. We have to take extra precautions to stand in front of it, because the exact solar radiation, it falls in our working area. So if you want to work exactly that solar radiation, we have to tune as air mass 1.5. If you want to work in a space, then you have to tune it accordingly. We can vary that radiation intensities. So it is a device. From that device only we are able to calculate that efficiency, and our material, it has to long last. So for that only I have highlighted that stability. It should be thermally as well as photochemically stable enough. Otherwise our compound will get charred over it.
Good evening, ma'am. You are using a ruthenium pipetals L749 die and ITO plate. They are very costly. Then how it is be cost effective?
Very carcinogenic. So nearly 10 power minus 6 or 10 power minus 9 molar solution is used for this study, and milligram level is enough, but it is toxic. We have to take care of it. The thing is, the excited state lifetime for ruthenium is very, very long enough, rather than when compared with iron or osmium, and even with other transition metals. They are not stable enough, and other transition metals, they won't absorb this much of energy, or that absorption spectra can't be swiped by other transition metals. So always we have to go for ruthenium polypyrrole complexes.
Question, ma'am. You are using so many organic compounds. How you can fix that that particular compound is useful for the harvesting solar energy by using quantum mechanical calculations?
Yes, sir. We can use organic dyes, can also be natural dyes, or also based on the toxicity. But the thing is, that is the idea. So they have shifted to that one.
What is the remedy for this?
No, it is not a hazardous, or it is not expelled directly to the environment, sir. It has been regenerated, and we can make use of the sensitizer once again. It is not abruptly thrown into the environment, and it won't be a hazardous one. So those sensitizers, it can be recycled. The turnover can be increased.
How many times it is reusable?
Nearly 5 times or 6 times we have tried in our laboratory.
After that, what is the next?
The very same sensitive, we have to store it only, sir. It can withstand up to 6 to 7 cycles, sir.
Okay.
So it is stable enough, and nearly more than 120 hours it can withstand in that solar simulator light also, stable enough.
Okay, ma'am, good.
one clarification from my side. So nice presentation, ma'am.
Thank you.
Out of ruthenium complexes for the sensorizer solar cell, which complex from your laboratories give maximum efficiency?
That bipyridine containing acid groups only, sir, because that anchoring group facilitates, and then three major reactions are important for that one. So this anchoring, it plays a major role, and also we have to prevent the recombination of that thing. So it has to be maintained, otherwise it won't hold good. People, we are trying to substitute more and more substitutions over that polypyridine unit, and we are checking whether at any one of the points whether the efficiency can be increased or tuned.
Thank you, ma'am. So I have one clarification regarding the stability of the materials. So whether it could be used in any weather condition, or it could be used only at summertime or winter?
We are checking the stability of the material by fabricating the cell and placing in the solar simulator that exact solar radiation. So we can't, some miles we are apart from sun, but the exact thing is come from that device, and by 90 hours or 120 hours we will check it out, otherwise the instrument will shut down. So it is highly intense one. So it is a stable one only. We have checked with even the less stable, as well as less stable in the sense organic dyes as well as metal complexes we have tried in our laboratory. It is stable enough.
So also one more question. So whether it could be reproducible, because e-waste is the next generation problem that we are going to face.
By replicate experiments only we will report. So I am damn sure reproducibility will.
Thank you, ma'am.
And we will squeeze the scholars and get the reproducibility. Thank you.
If there is any questions? So if there is no questions, I thank ma'am, Dr. K. Swarnalatha ma'am, for a wonderful session. Thank you, ma'am. Next, we will move on to the validity functions immediately. So please be in the lane.
you haven't learned is the size of the world.
The sun leaves us with a goodbye, but not our college. Alone in the college, the Department of Chemistry welcomes you with a pleasant evening to this valedictory ceremony of International Virtual Conference on Expanding Frontiers on Chemistry 23.
If your prayer is thanksgiving, that is sufficient. Here comes our student to thank God with a prayer song.
என்னான்மா இறைவனையே ஏற்றி போற்றி மகிழ்கின்றது என் மீட்பரம் கடவுளை நினைக்கின்றது என்னான்மா இறைவனையே ஏற்றி போற்றி மகிழ்கின்றது என் மீட்பரம் கடவுளை நினைக்கின்றது தாழ்நிலை இருந்த தம்மடியவரை தயையுடன் கண்கள் நோக்கினார் தாழ்நிலை இருந்த தம்மடியவரை தயையுடன் கண்கள் நோக்கினார் இந்நாள் முதலாம் தலைமுறைகள் இந்நாள் முதலாம் தலைமுறைகள் என்னை பேருடையார் என்றிடுமே என்னான்மா இறைவனையே ஏற்றி போற்றியே மகிழ்கின்றது என் மீட்பரம் கடவுளை நினைக்கின்றது.
Thank you, dear friends, for your soul-stirring performance. Shallow waters are noisy, deep waters are silent. Here comes a man of deep knowledge in chemistry. May I now invite Professor Deva Prince to welcome the gathering.
Respected Deputy Principal Dr. A. Sundaraj, Professor Dr. K. Sonalada, Head Department of Chemistry, Manonmanim Sundarnar University, Dr. S. Jagdiswaran, Managing Director, Biomi Live Analytical Center, Karikudi, Dr. S. Raipan, Head of the Department of Chemistry and Convener of this International Conference EFC 23, Dr. M. Amalraj, Organizing Secretary, juries of paper presentations, learned faculty members, my dear colleagues, students from other colleges and our own students, a warm good evening to you all. So I am greatly privileged and honored to welcome you all at this pulpit. A man of politeness, a man of simple outlook, a man of caliber, and above all, an able administrator, who is our Deputy Principal, Dr. A. Sundaraj. Sir, I am very deeply pleased and much delighted to extend my sincere and hearty welcome to you, sir. A young and energetic, dynamic and vibrant personality, a great researcher, renowned resource person, and an eminent speaker. He is amidst us. He is our chief guest of this valedictory function of this mega event, International Conference EFC 23, Dr. K. Sonalada Madam, Professor and Head, Department of Chemistry, Manonmanim Sundarnar University, Tirunelveli. I am very much happy to extend a very warm, sincere welcome to you, Madam. So it is a very surprise to welcome our Dr. S. Jagdiswaran, who is our own alumnus who studied here few years back, maybe around 10 years back, he studied here. He did his BSc here. After the completion of BSc, he further did his MSc in esteemed institutions, and he completed PhD, served as scientist, and now he owns a company that is called BioMe Live, that is analytical company. So that much great personality is here. He's a very good, entrepreneur. So he's a scientific entrepreneur. He has got projects in crores. So that's that much inspiring personalities amongst us. I am very, very happy to welcome our own alumnus, Dr. Jagdish Saran sir, to this valedictory program. Welcome, sir. So next, I am very happy to see many faces from outside colleges to share their knowledge, resources in these 2 days, yesterday and today. So I'm very happy. I was very happy seeing yesterday's oral presentation as well as today, post presentations. So really, I hope and believe that they have acquired more knowledge in this subject and shared their knowledge, spread their views, and I sincerely believe these 2 days will be very memorable days for them. I welcome all these dignitaries, these delegates of this 2-day program. I welcome all the scholars from various institutions. So moreover, it is very important to welcome our resource persons. So who acted as resource persons yesterday and today, who is here. And I welcome all the dignitaries, resource persons, juries of the both poster as well as oral presentations. So I welcome all these fraternities, faculties, eminent speakers, resource persons, and above all, I'm here very much delighted to extend my sincere warm welcome to our own beloved students who are the benefiters of this 2-day program. So I sincerely believe they would have acquired knowledge from the various platforms, the various friends from various institutions. So with these few words, I welcome you all once again, and I remain. So thank you.
Thank you, sir. When you give yourself for the welfare of others, be like a torchlight so that your light can permeate many hearts. Here comes such a magnanimous person. May I now invite Dr. A. Sundarraj to felicitate us.
Respected Dr. Rayappan, Head PG Department of Chemistry and convener of this 2-day program, International Conference on Expanding Frontiers in Chemistry. Today's chief guest, respected Dr. Swarnalatha, Professor and Head Department of Chemistry, Mannoenmaniam Sundaranar University, Tirunelveli. Today's guest of honor, Dr. Jagdish Saran, our own alumnus, who is also the director of BioMe Analytics. Outstation participants from various colleges and universities, faculty members of the Department of Chemistry, research scholars, and my dear student friends, good evening to all of you. I am very much pleased to offer felicitation in the valedictory function of this 2-day International Conference on Expanding Frontiers in Chemistry, EFC 23. I appreciate Dr. Rayappan and the organizing committee for organizing this conference, inviting eminent resource persons from different universities and institutions from different parts of the world. A special mention must be made at this moment. In addition to their regular teaching, they undertake research and publish papers and serve as resource persons, and also they arrange for financial assistance to support students to pay their college fees. AVR Fellowship is an example. I personally congratulate the department, particularly Dr. Raipan, for taking steps to get the financial support. Congratulations to Dr. Raipan and the department. Coming to the topics of the conference, in the 2 days conference, topics like computational and chemical biological approach for therapeutics development, waste recycling, bioenergy production, biomaterials and drug development, development of photocatalysts, development of organic electronic devices, and the molecular interactions are new and more relevant in current scenario, and expanding areas in the field of chemistry. And the organizing committee has given importance to these topics and covered in the 2 days deliberations. In addition to the topics deliberated in the conference, I would like to give you a brief information on a few more aspects of expanding frontiers in chemistry. The 2021 United Nations Climate Change Conference, COP26, held at the SEEC Centre in Glasgow, Scotland, United Kingdom, from 31st October to 13th November 2021, focused on various aspects and identified 4 important areas as expanding frontiers in the field of chemistry. In 2021, after a year full of medical challenges and big demand for chemical and pharmaceutical research, there were big advances in technology and algorithm developments to better understand and to predict the effects of various viruses and a number of other illnesses. And the 4 areas identified in the COP26 in the field of chemistry are sustainable chemical production, artificial intelligence as a predictor of viruses, improved efficiency for personalized drug treatments, wearable sensor which improve healthcare monitoring. So these are the 4 areas. And regarding the first area, sustainable chemical production, there is a need to go for sustainable production of chemicals or chemical production. We know that increased chemical production will lead to increased carbon production, leaving a carbon footprint. Therefore, there is a need to focus on decarbonization during the production processes. As a result, there will be an increase in investment in recycling technologies, looking at how to reduce emissions and reduce plastic waste which occur as part of the business as usual practices. Coming to the second focus on artificial intelligence as a predictor of viruses. With the repeated occurrence of pandemics, the industry focus is on improving the understanding of illness and other viruses, which led to vaccine research and effective treatment for those who are clinically vulnerable and are in hospital treatment. One of the achievements in vaccine research led to the development of rapid tests and vaccines for COVID-19 pathogens. This was possible with the sharing of databases with leading laboratories and with researchers around the world and sharing of genomes. In December 2020, artificial intelligence company DeepMind made a groundbreaking development when they announced that AI could lead to the long-standing problem of protein folding. This could help us to understand a wide range of cellular activities and reactions that occur in the cells in our bodies. Now we have established that the possibilities of what algorithms can predict for chemistry, much attention is paid to see what its capabilities are. For example, will it be able to predict drug binding pockets, improving both the efficiency and the effectiveness of drug development? And we can predict abnormalities in protein folding and what is its potential for mankind. All these things can be predicted or explored. Then the third one, improved efficiency for personalized drug treatments. Some of the most common pharmaceuticals available on the market and are made by a process of chaining. You may be familiar with the technology. This process is the basic structure of many medications used to treat physical ailments and diseases such as chronic pain and leukemia, as well as to manage a range of mental health conditions, including depression. As we know, there are a number of illnesses. Each of these illnesses and conditions is so vastly different from one another. Some require neurological chemical bonding and balancing, while others require transportation around the bloodstream to act on cells all over the body. Therefore, each of the medications we use to treat and manage these conditions require a different creative process. In 2020, a key emerging trend in chemistry was to simplify the process and make it easier to create medication for a vast array of illness at a much faster speed. Then the fourth aspect is wearable sensors, which improve healthcare monitoring. We know today in the modern and tech world, many of us lead a sedentary life. There comes the use of remotes, sensors, and automated devices that can turn on our lights, TVs, and other home appliances without moving and without lifting a finger. As a result, emerging technologies are also having an impact on our personal health, encouraging us to make small changes towards improving our physical and mental well-being. There comes greater access to telemedicine, physiotherapy, and even how to stay on top of our medications. The use of smartwatches are emerging as a popular piece of technology for many. We have already seen in 2021 how these wearable devices have been programmed with new algorithms to detect emerging illnesses, such as COVID-19, in an effort to overcome pandemics and other viral diseases. So we are excited to see how in 2023 and beyond, these technologies will be developed even further to improve the efficiencies between chemists and healthcare professionals. Smart watches can also improve your overall health by giving you access to apps designed around specific health conditions such as diabetes. Therefore, there is a greater scope for new and expanding areas in chemistry to create more resources and technologies to improve the lives of millions of people. You may think whether these aspects like wearable sensor will come under chemistry or physics. There is a question, there is a debate. It can be considered under physics as well as chemistry, under molecular biology and biochemistry, no doubt. We can very well discuss. These are the 4 areas focused in the COP26 International Conference, United Nations Conference. With this information, I thank Dr. Rayappan and the organizing committee for giving me this opportunity to associate with the Department of Chemistry and all the participants. I thank personally all the participants for your active participation, the outstation participants particularly. We thank all your principals, in charges for giving permission and making these 2 days a grand success. Wish you all the best. Thank you. Thank you, Ananda.
Thank you, sir. Nobody is bothered about an institution more than its alumni. This quote perfectly suits for our alumnus, Dr. Jagadiswaran. I'm glad to invite our senior brother to deliver his special valedictory address. Before that, I request Dr. Amal Raj to honor our chief guest, Dr. Jagadiswaran, with a shawl. request Dr. A. Sundaraj to present the memento. Thank you all.
அனைவருக்கும் வணக்கம். எல்லாரும் ரொம்ப டயர்டாக இருக்கீங்கன்னு தெரியுது. ஸோ ஐ டோன்ட் வாண்ட் டு ஸ்பீக் மோர், பட் ஐ எம் த alumnus ஆஃப் Arlanandar College. So I wanted to share some experience in this college. Actually, 2007 to 10, 3 years, it's a fruitful years for my life. ஒரு சின்ன வில்லேஜ் நியர்பை அறந்தாங்கி, புதுக்கோட்டை டிஸ்ட்ரிக்ட் அறந்தாங்கி, ரைட்? ஒரு சின்ன வில்லேஜ் நேம் கரவட்டான்குடின்னு சொல்லிட்டு, அங்கேருந்து ஒரு பையன் வந்து கவர்மெண்ட் காலேஜில் இடம் கிடைக்கல. அங்கே இடம் கிடைக்கலன்னு சொல்லிட்டு அருளானந்தர் காலேஜில் அப்ளை பண்ணுறேன். அருளானந்தர் காலேஜில் எனக்கு இடம் கிடச்சிருச்சு. எனக்கு அப்ளிகேஷன் போட்டது ப்ரொஃபஸர் ராயப்பன் சார். அப்ளிகேஷன் அவங்க தான் ஃபில் பண்ணி கொடுத்தாங்க. இடம் கிடச்சி வந்து இந்த 3 இயர்ஸ் ஒன்றுமே தெரியாமல் ஒரு தமிழ் மீடியமில் படிச்சுட்டு வந்துட்டு ஒரு 3 இயர்ஸ் அருளானந்தர் காலேஜில் இருந்துட்டு வெளியில் போனால் அந்த பையன் எப்படி இருப்பான், இட்ஸ் எக்ஸாம்பிள். ஐ ஆம் த எக்ஸாம்பிள் ஃபார் தட். ஆக்சுவலி இந்த அருளானந்தர் காலேஜ் தான் நீ எங்கே பிறந்த, உன்னோட ஃபைனான்சியல் சுச்சுவேஷன் என்ன அப்படிங்கிறதெல்லாம் முக்கியம் இல்லை. ஃபைனான்சியல் சுச்சுவேஷன் மீன்ஸ் எங்கள் அம்மா அப்பா 2 பேருமே வந்து கூலி தொழிலாளிகள் தான். ஈவன் வி டோன்ட் ஹேவ் எனி லேண்ட் ஃபார் த அக்ரிகல்ச்சர் ஆல்சோ. ஸோ அருளானந்தர் காலேஜில் வந்தோம், ஸ்காலர்ஷிப்பில் படித்தோம். ஒரு லோன் ஒன்று வாங்கி கொடுப்பாங்க, அந்த லோன் வாங்கி கொடுத்தாங்க காலேஜில். அதை வச்சு தான் படித்தோம், ஹாஸ்டல் ஃபீஸ் பே பண்ணோம். பட் த ப்ரொஃபஸர்ஸ், தே ஆர் வெரி டேலண்டட் அண்ட் தே ஆர் லைக் மை ஃபேமிலி மெம்பர்ஸ். இப்போ எங்கே போனாலும் யாராவது உங்கள் வாட் இஸ் யுவர் சக்ஸஸ் ஸ்டோரி அப்படின்னு கேட்டால், ஐ வில் ஃப்ராங்க்லி சே திஸ் இஸ் பிகாஸ் ஆஃப் மை ப்ரொஃபஸர்ஸ் அப்படிங்கிறத நான் சொல்லிடுவேன். என் பேரண்ட்ஸை கூட மென்ஷன் பண்ண மாட்டேன். என் பேரண்ட்ஸ் கூட எனக்கு இது பண்ண, ஏன்னா பேரண்ட்ஸ் அவங்களோட பொறுப்பு அவங்க செய்யணும் அப்படிங்கிறது எப்போயுமே உள்ளது தான். பட் என்னோடய ப்ரொஃபஸர்ஸ் அவங்க எனக்கு செய்யணும் அப்படிங்கிறது இல்லை. ஸோ நான் அடுத்த லெவலுக்கு போயிட்டே இருக்கணும் அப்படிங்கிறதுல எப்போவுமே வந்து இன்றைக்கி வரைக்கும் நியர் 2007 to 10னா இன்றைக்கி ஒரு 12 வருஷம் ஆச்சு. இன்றைக்கி வரைக்கும் நான் என்ன பண்ணிகிட்ருக்கேன் அப்படிங்கிறது டாப் டு பாட்டம் டாக்டர் ராயப்பன் சார் ஹி நோஸ். ஒரு 2 months ஒன்ஸாவது ஃபோன் பண்ணி என்னப்பா போயிட்டுருக்கு, என்ன ரிசர்ச் போயிட்டுருக்கு எல்லாமே விசாரிப்பாங்க. ஸோ எங்கே போனாலும் இப்போ நிறையா ப்ரொஃபஸர்ஸ் நமக்கு ஹெல்ப் பண்ணியிருப்பாங்க. பட் சில ப்ரொஃபஸர்ஸை நம்ம எங்கேயுமே போனால் மென்ஷன் பண்ணுவோம். எங்கே போனாலும் நான் மென்ஷன் பண்ணுறேன் மை வெல்விஷர், மை மென்டார் டாக்டர் ராயப்பன் சார். அதுக்கப்புறம் இந்த பிஹெச்டி கிடைக்கிறதுக்கும் அதுக்கும் ஒரு காரணம் வந்து அருளானந்தர் காலேஜ்னு சொல்லலாம். ஏன்னா நான் இங்கே முடிச்சுட்டு ஒரு கவர்மெண்ட் காலேஜுக்கு, சேம் கவர்மெண்ட் காலேஜுக்கு போகிறேன். அங்கே எனக்கு இடம் கிடச்சிருச்சு மறுபடியும் எம்எஸ்சிக்கு. அங்கே போயிட்டு இருக்கும்போது எல்லாருக்கிட்டையும் என்னோட ஒரு ப்ரொஃபஸர் கேட்குறாரு, நீங்கள் அடுத்து என்ன ஆகணும் அப்படின்னு கேட்குறாரு. எல்லோரும் சொல்கிறாங்க நான் போலீஸ் ஆகணும்னு சொல்கிறாங்க, ஒருத்தர் கார் வாங்கணும்னு சொல்கிறாங்க, ஒருத்தர் டீச்சர் ஆகணும்னு சொன்னாங்க. அதில் நான் மட்டும்தான் சொன்னது சார் நான் பிஹெச்டி பண்ணணும் சார் அப்படின்னு சொன்னேன் அவர்கிட்ட. ஸோ அது ஒரு நாள் ஏதோ சும்மா அப்படி ஒரு பேச்சுவாக்கில் அப்போ நடக்கும்போது நடந்த டிஸ்கஷன். ஆஃப்டர் மை எம்எஸ்சி ஒரு நாள் வந்து அந்த சேம் ப்ரொஃபஸர் எனக்கு ஃபோன் பண்ணுறாரு. இந்த மாதிரி என்னோடய ஃப்ரெண்டுகிட்ட வந்து பிஹெச்டி வேகன்சி இருக்குது, யூ கேன் கோ அண்ட் மீட் ஹிம் அப்படின்னு சொன்னார். ஸோ அந்த ப்ரொஃபஸர் யார் அப்படின்னா, ஹீ இஸ் ஆல்சோ அலுமினி ஆஃப் த அருளானந்தர் காலேஜ். அதுக்கப்புறம் அந்த ப்ரொஃபஸரை போய் மீட் பண்ணி நான் பிஹெச்டி ஜாயின் பண்ணிட்டேன். அது அப்போ வரைக்குமே என்னோடய ஃபைனான்சியல் சுச்சுவேஷன் சேம் தான். பட் ஐ டோன்ட் திங்க் அபவுட் த ஃபைனான்சியல் நம்மளால் முடிச்சிட முடியுமா, பிஹெச்டி முடிச்சிட முடியுமாலாம் திங்க் பண்ணலை. அந்த கான்ஃபிடென்ட் கொடுத்தது எனக்கு அருளானந்தர் காலேஜ். அந்த முடிச்சிடலாம், ஏன்னா யூஜி பிஜியே முடிச்சிருக்கும் போது பிஹெச்டி முடிக்க முடியாதா அப்படின்னு சொல்லிட்டு முடிச்சதுக்கப்புறம் ஐ ஒர்க் யங் சயின்டிஸ்ட் 2 years இன் சைனா. நவ் ஐ ஸ்டார்டட் மை ஓன் பிஸ்னஸ். இந்த பிஸ்னஸ் ஸ்டார்ட் பண்ணும்போதுமே நிறையா நெகட்டிவ் தாட்ஸ் இப்போ நம்ம ஃப்ரெண்ட் சர்க்கிள்லேருந்து வரும்ல, இதெல்லாம் பண்ணிடலாமா அப்படின்னு. But we started and we are successfully running now with 8 scientists in Biomi Live Analytical Centers now in different expertise. So, to my juniors here in Aralanandar College, you have a very good place for study and you are learning things. அதோட இன்னொரு விஷயம் நான் ஐ வாண்டட் டு சே ஹியர், நான் வந்து பெரிய ரொம்ப இன்டெலிஜென்ட் ஸ்டூடெண்ட் ஐ ஒன்ட் சே ஐ எம் நாட் இன்டெலிஜென்ட் ஸ்டூடெண்ட். என்னோட பர்சன்டேஜ்லாம் பார்த்தீங்கன்னா ரொம்ப ஆவரேஜாக தான் இருக்கும். பட் எக்ஸ்ட்ரா கரிக்குலர் அருளானந்தர் காலேஜில் வந்து எக்ஸ்ட்ரா கரிக்குலர் ஒரு ஃபங்க்ஷன் ஆர்கனைஸ் பண்ணணும் அப்படின்னா திஸ் இஸ் த வே ஆஃப் ஆர்கனைசிங் த ஃபங்க்ஷன் அப்படிங்கிறது வந்து அருளானந்தர் காலேஜில் கற்றுக்கலாம். அண்ட் தென் எக்ஸ்ட்ரா கரிக்குலர் நான் இங்கே படிக்கும்போது ஒரு 30 நாளில் மேக்ஸிமம் ஒரு 5 days ஒரு 5 days 10 days வந்து வேறு காலேஜில் இருப்போம். நிறையா காம்படிஷன் போகிறதுக்கு, அது மாதிரி என்எஸ்எஸ் என்சிசி இந்த மாதிரி. நான் என்எஸ்எஸ் இங்கே ஐ எம் த செக்ரட்டரி ஆஃப் என்எஸ்எஸ் ஹியர் நான் படிக்கும்போது. ஸோ என்எஸ்எஸ்லாம் இருந்துச்சுன்னா நல்லா யூஸ் பண்ணுங்கள். அதெல்லாம் வந்து யூ கேன் லேர்ன் மோர் திங், ஹவு டு ஸ்பீக் இன் ஸ்டேஜ் அண்ட் நிறையா எக்ஸ்ட்ரா கரிக்குலர்ஸ் யூ கேன் லேர்ன். So this is a thing, and I congratulate and my best wishes to my well-wisher, my Professor Rayapan sir and their team for this grand success of this conference. Thank you very much.
Thank you, sir. All our dreams can come true if we have the courage to pursue them. By Walt Disney, our chief guest has the courage to pursue them. I am privileged to invite Dr. Swarnalatha to deliver her valedictory address.
Before that, I request Dr. Savita ma'am to honor Dr. Swarnalatha with a shawl. And I request Dr. A. Sundarraj to present the momentum.
Beloved Deputy Principal, Deva Prince, Faculty of Department of Chemistry, respected Head of the Department, Professor S. Rayapan, and Dr. Amal Raj, Assistant Professor, Department of Chemistry, and all other faculty members of Department of Chemistry, and participants and student friends of Department of Chemistry, Arulananda College. A very warm good evening to all of you. Again, they have given a tough task. Almost all the people have delivered their speech, and I know how difficult to deliver a talk at the end, and also we are almost towards the end of the conference. I know for the past 2 days you have been dumped with many informations. Yet, though they have given enough things, let me add 2 more points what they have added. One is, we know science of today is technology of tomorrow, and everywhere in the coming week we are going to celebrate Science Day, and then the science and technology, it can't be inseparable. And that is the topic for debate, essay competition, and whatever may be. But yet, I have borrowed the quotes or information from our great legend, Dr. Abdul Kalam. He has pointed out that in one of his lectures, always we borrow examples from other countries are not from India to quote the scientific informations or innovations. So why that scenario? Once I have went for one Board of Studies meeting. So there one industrialist, he pointed out that You have mentioned that you have edited and then you have written 2 books and 2 chapters, and why those things are not coming under the references in the syllabus where we are lacking. So likewise, they have pointed out all the time we are referring the textbooks of foreign authors and other countries only. So in what way we are lower than their ability, or what is the sources lack in our country. So why we are often telling examples from other scientists or other countries. So that is the scenario. Though we are doing research and almost we have touched the application part. Okay. So, and also our deputy principal, he has rightly pointed out in the another years, we people will be ruled by artificial intelligence, the technology only. Artificial intelligence and data science or data analytics is going to rule over us. Okay, so though we are chasing or almost running towards the application end of it, we people are lack in the fundamentals. So I request all the youngsters and our graduate students, so be strong in the fundamentals of what we are learning here. Then only we will able to touch or we can reach the application. So that is very, very important. So another thing is the technology, we can't separate the science and technology. Those two things are sides of the coin. Okay, so my 8-year-old kid, she used to tell, how is your grandfather or how is your great-grandfather? Likewise, if any of our relatives or friends asking, she used to tell, he will talk only with the technology and not with me, and he will not play with me. He used to play with that tablet only, likewise she used to. So starting from 8-year-old kid to 86-year-old grandfather, everywhere we are making use of technology. And another abrupt thing, that mobile, almost we people are addicted towards that mobile. For each and every 5 minutes, we are opening that and then check whether, even though messages are not coming, we are very curious in viewing all these things. So unnecessarily, we are doing lot of things. So I request and I highlight that, please, the young minds, don't make your mind as a garbage of dumping all those things. So this type of events, international conference, definitely will be an eye-opener for the young minds, because we people, we are sitting here means, likewise we people are there in one stage. So at that time, a sudden spark or something, you will get an exposure about the next step of your life. So you people, please stick on to that thing prescribed by, not only go via that syllabus, you learn extra things. Okay, so learning process is a never-ending process. So I request all the people, all the youngsters to work with a team. Okay, and also you please welcome the change in whatever aspect. So, and then work as a team and also have fun, but it should not ruin your daily activities. So that is the thing. And once again, let me complete with the famous quote by Vairamuthu, that since we people are doing research and then scientists or chemists or scholars, whatever may be, so our job is not converting all your desalination of water. Okay, so கடல் நீரை குடிநீரை ஆக்குறது மட்டும் நம்மளுடைய பொறுப்பு கிடையாது. கண்ணீரெல்லாம் பன்னீரா மாறணும்ன்றது தான் நம்மளுடைய இது. So our research, it should be a small contribution for the welfare of the society. So I wish you all the best, and also I thank Dr. Rayappan for giving me this opportunity, and once again I thank all the team members who are working behind this wonderful international event. Thank you. Wish you all the best.
Thank you, ma'am. My dear professors and my dear friends of other colleges, hope you have enjoyed the 2 days at our college. Maybe the ambience, the surroundings, food, collaboration, importantly the presentations. There is a word called magis in our institution, meaning more and greater. In Tamil, innum adhigamaga. We'd be happy if you give your valuable suggestions so that we could enrich the program in the coming years. So I request the participants and the professors to give your valuable suggestions now.
Good evening, everyone. I'm Ida from VIT University in Chennai. I know as a grown scholar, I really know the pain of organizing a conference. That too, a 2 days conference, and it's an international conference. It's really a well-organized one. And thank you for giving such immense pleasure to present in people who are very much knowledgeable. And the sessions that you have conducted also, not only it's based on a same topic, it was really a vibrant one, and different topics have been conducted. That was a really nice move. And also, I really need to thank the faculties that I have registered in the last moment, I think in the last day of the day that's been mentioned, and they have acknowledged me kindly. And really, I need to thank all the faculty members. And also, I have noticed all the students have participated in this conference to make it as a successful one. Not only the people who were in the committee, everyone has worked for this conference, I think. So it has really become a successful one. And I once again thank all the faculty of the college and the management for giving such a good opportunity. Thank you.
Thank you. All the respected dignitaries on the dais and all the respected persons and students, research scholars, good evening to all. I was attending this program, and not only a program, you know, it's an international conference, attending from tomorrow onwards. Even I couldn't find any negative, because all the sessions and other programs, food, everything are arranged in a well manner there. Actually, the privilege of the section is going to the students of our college. The reason is that I just take word from our Dr. Sir, so they get an opportunity how to organize the programs. Okay, it's a better privilege to the students. I thank to all the members who worked behind this, especially thanks to backbone of the program or the conference, the convener, Dr. Appan sir. Please give a big applause to sir for conducting this type of conference. Thank you very much. Thank you, sir.
Respected Principal, Head Department of Chemistry, and all faculty members and students and participants of this conference, a very good evening to one and all. So, a program of this event cannot be planned overnight. So, a lot of work has to be done behind us. So, organizing such an international conference is, planning is very difficult and execution is more difficult. In that way, they have given, I think, Arlanandar College, they have given a good justification, a great applause to them. Kindly give them a great applause. And also, I thank the management for giving me this opportunity of doing a poster presentation. And everything was good. So, communication, the way they, receiving the abstracts, communications, the way we came here, and the food they gave, and everything, it was excellent. So thank you so much. Thank you. We are expecting more from you. Thank you.
Thank you, ma'am. Anyone? Any professors or scholars?
From student side, I'm expecting student side because
A warm good evening to one and all. We already came to this college. We have more of competitions always. Every competitions they will show what they are. So they are always extraordinary, and today more than that. Thank you so much, sir. Thank you so much, sir, for arranging this, and you are always known for your hospitality that will always keep you over heights. Thank you so much.
Thank you. Any volunteer to appreciate or give your suggestions? Thank you for your valuable suggestions. Now, it is the time to reward our participants and winners of the competition. May I now invite Dr. Amal Raj to read out the winners.
So, dear participants, before we go for the best oral and poster presentation awards, let me ask our convener, Dr. S. Rayapan, to honor our one of the jury, Dr. Mahalakshmi Madam. Please come out to the stage, Madam, please. Yes, for the last 2 days, he was with us and she evaluated the oral presentations. Thank you so much, Madam, for your contribution to the conference. So now let me announce the best oral presentation, best poster presentation awards first. See, these are not categorized into first, second, third. These are the best presentations. Okay, so there is no first, second, third in research. Okay, the poster presentation. Let me go to the poster presentation awards. The first, that is the best poster presentation award goes to Miss K. Brinda, first PG student, Fatima College, Madurai. And I request our deputy principal to give away the certificates. The next best poster presentation award goes to Ms. P. Rama from MS University. Research scholar, MS University. There is actually the madam has to receive the certificates because the students are not here. I request the madam to receive the certificates on behalf of the students. Then the next award goes to the Mr. A. Ajish Kumar, Research Scholar, Jamal Muhammad College. Please, sir. Now I request Professor Dr. Swarnalata Madam to give away the certificates for the Best Oral Presentation Awards. And the Best Oral Presentation Award, that is actually the virtual presentation is also conducted. It goes to Ms. C. Nandini from National Taipei University, Taiwan. And we'll be sending the certificates through online, so there is no official presentations here. And for the Best Oral Presentation Award goes to Mr. Raja Alangaram Abina from Madurai Kamaraj University. The next best this oral presentation award goes to Ms. B. Shobana, Research Scholar, Tyagaraja College. I request Dr. Jagadiswaran to give away the certificates. The next best oral presentation award goes to Miss Ida Angel Priya from Vellore Institute of Technology. So next, thank you dignitaries. So almost we come to the end. Actually, all is well if everything ends well, right? So let me here to propose the vote of thanks as well. And first of all, I would like to thank the God Almighty for their blessings and felicitations. You know that without the support of God, this cannot happen. And in the side, actually outside, I would like to thank Reverend Dr. John Prakasam SJ, the rector, and also the, as Father mentioned in the inaugural address, he is the head of the institution as well as the head of the department also, almost like, he is leading us in all possible ways and he is suggesting in all the ways. He is the one who is supporting in all the possible ways. So I wholeheartedly thank Reverend Dr. John Prakasam SJ, Rector, Arlanandar College. Thank you, Father. Next, I would like to thank Reverend Dr. Gilbert Camillus, Secretary, for supporting us in all possible ways, that the financial support of the conferences has been made by means of the Father. And also, that it is not only the financial support and also the support in all possible ways. So I thank Reverend Dr. Gilbert Camillus, Secretary. Thank you, Father. Next, I would like to thank our dynamic principal, Reverend Dr. Godwin Rufus, SJ, for his inaugural address. You know that he taught us, if you didn't see the inaugural address, it is available in our Media Center YouTube link. Please go and watch it. He has effectively shown how to use a waste water bottle into a useful way. We are researchers should think like that. He always used to think the pupils and particularly the students to think in the out of box. If you didn't say here, please go and watch. It was really inspirational. So thank you so much, Father, for your inspirational words. Next, I would like to thank our Deputy Principal, Dr. A. Sundarraj, for his felicitation in the valedictory program, and also, that constant support to the department. Whenever we go and approach, he always says, sir, do this, do like this. He always gives suggestions in order for us to improve. Thank you so much, sir, for your kind support, and we are also looking forward to more from you. Thank you, sir. Next, I would like to thank all the invited lecturers, particularly starting from Professor Dr. K. Murugabubudi Raja, Central University of Kerala. Then, actually, the foreign professors, that is Dr. Chittapon from Kyushu University, Japan. Then Professor Dr. Seyaduraman from Central University of Tamil Nadu. Then Professor Mayur B. Karude from Hanyang University, South Korea. Then Dr. Mahendran Velachami from Institute of Joseph Stephen Slovenia. And Dr. Jagadiswaran, our old alumni, the Director of Biomi Analytics, Karaikudi. And then Professor Dr. K. Swarnalatha, Manonmaniam Sundarnar University. We thank all the invited lecturers for their excellent contribution, excellent presentation, as well as engaging the students with a lot of their knowledge. Thank you so much, all the invited speakers. Thank you, sir. Thank you, ma'am. Then I would like to thank the juries, particularly Dr. J. Jayasundari Madam from SVN College, and Dr. M. Rajan from Madurai Kamaraj University, and Dr. V. Tamilmani from the Anna University Campus Trichy, and then Dr. R. Mahalakshmi from Tyagarajar College, and then Dr. K. Karthik Kumar from the American College, Madurai. So these people have done a wonderful job. There are 81 abstracts. It is not easy to sit and evaluate. It's a bit difficult job. All of them has done well. As I told you, there is no best presentation. There is no best research in the world. Everything is best. Out of that, selecting a person is not an easy job. We thank all the juries for their wonderful job. Thank you so much. Then I would like to extend my thanks to the Pastoral Director, Reverend Dr. Anbarasu, for arranging the accommodation for our outstation students. Thank you so much, Father. Then I would like to thank Reverend Father Inasi John for arranging the food and refreshments for the conference. Thank you so much, Father. Then I must thank these extraordinary pupils. We know that this is something like, big job, preparing the conference proceedings. I would like to thank our editor-in-chief, particularly our head of the department, that the convener as well as the chief editor of this EFC conference. I thank you so much, sir. Not only this editorial board, he has done so many of things. Thank you so much, sir. And also particularly I thank Dr. Kombaya as well as Dr. Yesuraja for preparing this conference proceedings. It's a very, very difficult job. Till the last minute we received the abstracts. They keep working. They were working continuously to bring the book. And also I extend my thanks actually all the professors. I cannot say that one was preparing here, one was going for the printing and all. It was a tough job. Thank you for all the professors. I don't want to mention individually, but everybody has contributed in preparing this conference proceedings. Thank you so much. And particularly the one who makes the valedictory, what is that, vote of thanks in a special way in the inaugural session. Dr. Yesuraja, he teaches some chemistry also in the inaugural. So you can see the responses from the applauses itself. It was an excellent job. He has been with me actually till from the beginning to the end. He was coordinating the things. Thank you so much, Dr. M. Yesuraja, sir. Thank you so much. Then I would like to thank all the pillars of the department, all the professors. I don't want to, I have put up all the photographs starting from Savita madam and Deva Prince sir and Dr. S. Martin, Yesuraja sir, Jansi madam, although she is absent today, she has done the job. But Dr. Janji Bagan, Dr. Michael Raj and Dr. Kombaya. So all credits goes to them. Each one take one responsibility and have done their job perfectly. So without their support, it is not at all possible. The perfection comes only with the cooperation. The cooperation from the faculty's members should be highly appreciable. Thank you so much, all the professors. Then I would like to thank our sponsors, particularly Dr. Jagadiswaran, the director. He has sponsored the conference bags. Who might have enjoyed this. The conference bags is a very nice kit. So thank you so much, sir, for your generosity in giving the sponsor. And also we also thank Sign FX Notebooks, Madurai, for providing the conference. Notepad. Thank you so much. Next, I would like to thank the participants, the professors, research scholars, students from various other institutions. Say, without your, actually when we begin this EFC 23 in the department meeting, the discussion, sir, shall we go for online? Because will the pupils come? The COVID situation, online meeting, will it bring the pupils together? No. We sit together, we had a lot of discussion. We thought of going for online virtual session. Then, that's what our discussion was. But last year, EFC 21, we conducted completely through online. Only we received 56 abstracts. But this time, it is 81, and the total number of participants close to 100. This shows that people still wants to come in person rather than meeting in online. So I really thank all of you for coming together and making this as a great, successful one. Thank you so much, all the participants. And I would like to thank our own professors and the participants from the other departments like physics, RDS, and FST for participating in this conference. Thank you so much. And this I should mention. Without these pupils, it is not at all possible to make this conference a successful one. First of all, I would like to thank the student secretary, Ms. Selvi. I don't know, she is not here. Yes, she is here. And the coordinating the students for various committees, she is the one. She is doing great till from the beginning of the academic year, and this is one such example. She has done her job well. So thank you so much, the student secretary, and also the volunteers for various teams, prayer song, prayers still from the prayer song, registration, reception, and also the MC team, and also the hospitality team. I can list down. It's okay. If I miss something, please kindly excuse. Okay, students, please kindly excuse. And particularly special thanks to the third year UG as well as the second PG students. They have done a great job. They were here till from the beginning to the end, and still the students are doing some works. Okay, after that also they have to do some works. They will stay with us till the end. And thank you so much for your support, students. Thank you so much. Then I would like to thank these special peoples, Media Center. YouTube live streaming was parallelly going on, and some of the peoples are enjoying the same conference from even from the Taiwan. Peoples are still watching the conferences just because of these peoples. Media Center. I especially thank our Media Center coordinator, Mr. Vijay, from the coordinator of Media Center, as well as the member. He is also with us, Dr. K. Kombaya, and also now he has done 50% of the work. This is actually since 3 of our invited lectures are from abroad. If we go for only live streaming only, this will be in great success. And that has been done, taken up by Dr. K. Kombaya. Thank you so much. And also I have to mention these 4 names, Mr. Mithun, and Mr. Charles, Mr. Handon, and Mr. Alex Rayapan from our own department. Thank you so much, boys, for your support and help. Okay, thank you so much. Next, I would like to thank all the office members in both shift 1 and shift 2 office. And I would like to thank the non-teaching faculty, particularly Mr. Pungudi, in assisting the lunch and other arrangements, and also the technical peoples like Mr. Chinnapan, Mr. Suresh, Mr. Arokya, Mr. Dhanabal, and Mr. Sendil, and Mr. Jayabandi, and also the housekeeping staffs. Suppose, in case if I forget any names, kindly excuse. Thank you so much, and thank you one and all.
Thank you, sir, for your enchanting Thanksgiving. Now, let's all stand up and sing together the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तब शुभ नामे जागे जब शुभ आशीष मागे जाहे जब सैयदादा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you.
I request the participants to collect the certificates from the registration desk, and also those who won the best presentation awards are requested to sign in the receipt so that we can credit the cash prize to your account. Thank you.